Good morning. Today we are correcting CO65, our last objective of this unit. We were working on those circle graphs and being able to interpret them. What big thing did we learn when we went over this objective? What do we have to remember? Liam? Percent. And how to find those percentages. Because those circle graphs use percentages. So the big thing we have to remember is that part equals percent times the whole. So we use that percentage equation to help us find answers. So it is important that when we go through our review and we make those help sheets, Ava, where should your attention be? When we go through our help sheet, we need to remember this equation because it will help us to answer those questions and be able to interpret the graphs and answer our questions. So the circle graphs use percentages, and we need to know that equation to help us answer. Let's look at our second page that we worked on by ourselves. What would be a reasonable title for this circle graph? So if we're looking at what's all in the graph, a good title would be the monthly budget. How much you spend monthly on these different things. What other titles did people put? Connor? Okay. So the only problem with just writing bills is this one's labeled saving. So we have to be careful that we're looking at everything. I first would say, oh, bills make sense because, we've got grocery bills, we've got utility bills, and our car bills. But then we have that section that says savings. Well, that's not really a bill. It's how we're dividing up our money. Layla, what did you put? Money wasting? So do you really think it's wasting money to pay for these things? Say it louder. So this doesn't have to do with math, but just life experience. Paying for things is not wasting money. Okay, especially when we look at that groceries isn't wasting money. If it were to say what I'm spending on pop, what I'm spending on candy, what I'm spending on fruit, what I'm spending on vegetables. So some of that I could say is wasting money because I'm spending it on stuff that isn't good or healthy, but groceries in general wouldn't be a waste. So when it comes time to take the test, if there is a question like, give this graph a title, we want to stop and think, what would be an accurate title for the information the graph is giving us? So really read through every piece and say, what do all these things have in common? Okay, we're not just going to put down any old title. We want to really think what would be a proper title for this. If a paycheck is $2,000, how much money is put into savings? Sometimes if we don't know a title right away, reading the questions might help us break it up and say, oh, these questions are all about paychecks. That's going to help me maybe answer the title of the graph. So if a paycheck is $2,000, how much money is put into savings? $460. How did I get that? What math did I do to get $460? Give me a thumbs up if you got $460. How did you get it, Mel?
I don't have my work on here, but I'm pretty sure I did 0.23 times 2,000.
Okay, so remember our equation. Part equals percent times the whole. So we want to know the part. we want to know savings. So that is our part. And if I look at savings, I see it's 23%. So that's how Mel got that 0.23. And then we want to multiply that by our whole. Our paycheck is $2,000. So that's why Mel did $2,000 by 0.23, because we're using that equation. That's how she found out that the part was 460. The next question, if $180 is spent on utilities, how much is the paycheck? It is $1,500. Thumbs up if you got $1,500. Yeah, there's a lot of thumbs not going up. We are using the exact same equation, but this time we know our part. Our part being spent on utilities is $180. And utilities is 12%. So I put in a 0.12 for my percent. And I want to know the whole. So to get the whole by itself, what do I have to do with that 0.12? How do I get the whole by itself, Mel?
I don't know.
So if I look over here at utilities, what is our percentage for utilities? That's how I got 0.12, because that's the utilities percent. Does that make sense?
Yeah.
So I'm going to divide by that 0.12 and divide by 0.12. And I get left with my whole by itself. 180 divided by 0.12 gives me that $1,500. So that equation is important to use. If $725 is spent on groceries and on dining out together, how much is the paycheck? Well, for my percent, I need to look at dining out and groceries. I'm combining them together. So my percents have to be added together. And my part was the $725. The percent is 21 plus 8. So I have to add those two together because I combined them together up here for 725. So now I combine them down here to get the 0.29. I have to add the 2% together. I'm timesing it by the whole. So what do I have to do with that 0.29? I want whole by itself. What's my opposite operation that I have to do? Marina, what would be the opposite operation that I have to do? Yeah, because I was multiplying. So now I need to divide by that 0.29. So 725 divided by our 0.29 gets me 2,500. Cam, I'm not sure what you're doing, but it's certainly not math. We don't need a backpack in our lap. We don't need fidgets in our hands. We need to be following along. There are a lot of people who struggled with being able to interpret our circle graphs. We have to be able to use our percentage equation and be able to fill in the parts to answer it. There will be questions like that on the test. Truly, you have to be able to use it. Marina, I really need you to stop staring at the people at your table because I can tell we're not focusing on the math. So if you need to move, it might be wise because we have this practice test tomorrow. And it's okay for you to move to the back table. Okay, then I don't want to see your giggling and your smirking. I want to see us focus on the math so we can try to do the best that we can do on the test. How do we feel about these three parts now that I walked us through it? Show me your thumbs. How are you feeling? What important thing do we have to put on our help sheet? The equation. Part equals percent times whole. We have to remember to use that and how we use it. If we're solving for the part, if we're solving for the whole, we have to be able to use those. Let's look at our next circle graph. What would be a reasonable title for this circle graph? I put sport preference because there's all these different sports that are listed in there. What did you guys put, Claire? Sports. Yeah, even just calling it sports, that would be fine because they all have to do with sports. Which three sports together had more votes than cricket? Oh, right there, it tells me what these votes mean, or what these sports mean. People were voting on them. That's how I got the preference in my title. So it's not just sports, but it's sports preference or sports choice. Okay, so sometimes reading the questions that come after help us give us the title. So what three sports together had more votes than cricket? We have to add them together because cricket obviously is the biggest choice, right? So what three together are bigger than that? That would be football, hockey, and tennis. If we add those three together, it's more than 39%. If two people voted for golf, how many people were surveyed? So, two people would be what part of our equation? Would it be the part, the percent, or the whole? Two people voted for golf. Two people is the whole. Two people, can people be a percent? What's the last section? The part. Two people are the part. What percent am I going to put? 4%. How do I write that as a decimal? 0.04, because remember, percents always go to that hundredth place. What we want to know is how many people were surveyed, how many altogether, the whole number of people. How did I get 50 using that equation? What math do I have to do? Madison, please stop. Ava?
For some reason, I got about 49.
So what math did you do?
I think I added.
Yep, is that the math that we needed to do, Ava?
No.
So would about 49 be the number of people surveyed? No. So you were close to the right number, but we can't guess. Okay, when we do reading graphs, we have to know fully what math we're doing to get our complete answer. There's not about 49 people that were surveyed. There was an exact number of people surveyed. Using this equation, how did I get 50? Connor?
I think I did it a different way than you, but I added 10 percent, hockey percent, each football percent,
Mm-hmm.
and then I divided it by 2, and then I don't really know.
And what did you get for your answer, Connor?
I didn't write it down.
So Ava did adding, and she got about 49 because she was kind of doing a guessing. You were doing some kind of adding, trying to figure out, is that going to give us our specific number? No. So when we do this, when we have 2 equals 0.04 W, we want to get W by itself. What math operation is happening right here when there's a number in front of our variable? What operation is this? It's multiplying. So I have to do the opposite operation to get that W by itself. So I need to divide by 0.04 and divide by 0.04. So when I look at my equation, I have 2 divided by 0.04. That's how we get the 50. This is proven by the math. There were 50 people surveyed. I can prove it. The math tells me. I'm not going around trying to do some adding. If I did this, do I get that number? There's a lot of people looking around at other classmates and smiling. And that is telling me that we are not focused on the math. Whether or not we are paying attention, the practice test is tomorrow. Real test is Wednesday. I am trying to help you understand how we get these answers because a lot of us did not do it correctly. So it's a little disappointing that you don't care about your math right now. Truly. I know how to do this math. I can take the test right now and get 100% on it. I'm trying to help you. So when you're not putting forward your energy because we're busy coloring on our hand instead of paying attention, tells me you're probably not going to do so well on the practice test. You're probably not going to do so well on the actual test. It's your responsibility as the student to be understanding our mistakes, to be learning how to do the math. Sometimes we can do guess and checks to get answers when we don't know what math to do. Do we have to do guess and checks on this math? No, because we know exactly what to do. We should know the equation to use now. I understand on Thursday we weren't sure what to do, so we did do some guessing and checking. On the test, should we guess and check? No, because I am making sure we know the equation to use. So you should be able to do this on the practice test tomorrow. Because I'm trying to drill it into you to use this equation and how to use it. Because I want you to learn it and understand it. Connor? Okay. Oh. How did you get 50?
I divided 2 out of 100
Mm-hmm.
because I thought like 100 is like how many people are normally in it, but since it's 4%, then only 2 people can add it, and I probably would divide by.
So with a circle graph, the 100 would be 100%. So everything in the graph, if we added all those percents together, that's where 100 comes in. It's 100%. But that is not how many people we always survey. It's not always out of 100 people, this many choose this. If I surveyed our class right now, I could make a circle graph, and there are 20 of you in here right now. So if I surveyed us right now, what is your sport of choice? I could make a circle graph with different percentages. All those percentages would equal up to 100. We can't assume it's always 100 people. Okay, so that's where we have to be really careful with. It's 100% for the graph, but there can be different numbers of people that are surveyed. So I'm glad you figured out where you got your number from. All right, if 60 people voted for tennis, how many people voted for hockey? Oof, this is a multi-step problem. So let's see how we should solve this problem. If we're going to look at the information that we know, 60 people are our part, right? 60 is the part, voted for tennis. So what is our percent for tennis? 12%. So we need to know how many people were surveyed all together. So I'm going to do that math again. And we're going to say 60 What do I have to do with my 60?
Divided by,
You're right.
divided by 25.
Because I want to get the W by itself, so I do my opposite operation. So I have 60 divided by 0.12. That gets me 500 people altogether were surveyed. So now I want to know how many people chose hockey. So now my part is the question. I know hockey is 18%, and I know my whole is 500. So it were 2 steps I had to go through in order to get to the hockey. I had to use my tennis information, and what was missing was the whole. Now I can use the whole and the percent to find out hockey. So now I have 0.18 times 500. And that's how I get 90. 90 people surveyed were hockey. So sometimes we will have multi-steps that we have to do to get to our final answer. Does that make sense?
Yeah.
So it was complicated trying to figure it out for ourselves. That's why this was homework, for us to learn from it. You will have to do some multi-steps on the test. So use the information that you know, see what's missing, and then use that for the second part of the question. Use what you know, find what's missing. Still using that same equation of part equals percent times whole. We just had to do it 2 different ways. Show me your thumbs. How are you feeling now that we've walked through it? It's okay if we're still, I'm not sure. Some of us are like, ooh, I feel a lot more comfortable. Some of us need a little practice with that percent equals whole time, or part equals percent times whole. All right, let's look at our review. Shh. Look at what I did to help keep it straight in my head. I looked at every graph and I said, what do I use that graph for? Bar graphs are used for quantity. Line graphs are used for value. Stem and leaf plots are used to put things in order. Box and whisker plots are used to find the range and the median. Histograms are used for frequency, and circle graphs are used for percentages. On our help sheets, for every objective, for each graph, you need to put what they are used for. This is something you need to know. I'm telling you right now, if you don't know what each graph is used for, you're probably not going to pass those objectives. That's going to be a question on the test. So knowing what each graph is used for, the times people are finishing a race using 5-second intervals. Which of our graphs have intervals? That's the histogram. That's what frequency means. Remember, on the bottom of the histogram, we always had intervals. So I know that's the histogram. The results of a class survey of everyone's favorite M&M color by quantity. So the quantity is the bar graph. The number of views on your YouTube channel to find a trend. That would be our line graph. That one I wasn't as sure about. Who do you know? Other room. I wasn't as sure about this one, so honestly I left it blank. And I filled in the other ones and saw what was left and asked myself, did it make sense? So here, the number of tacos on your food truck sells each day. To find the range and median, I know the box and whisker I used to find range and median. So this one was quantity. So the results of a class survey of everyone's favorite M&M color, but this time by percentage. I know percentage is the circle graph. And the last one, ordering the minutes you spend on social media each day to find the median and mode. So I'm putting things in order and median and mode. are both stem and leaf plot. So that left me with that line graph. And I said, what, could I make a line graph to see my number of views on the YouTube channel? Yeah, I could. So that's how I filled in that last one that it wasn't quite as certain of. Any questions on those? All right, if you are watching this at home, please remember tomorrow is our practice test. The next day is our real test. Make sure you are working on your help sheet and make sure if you can ask me questions if you have any. Have a wonderful day.